Thank you. So again, welcome to BristleCon 2025. This is an amazing event for all of us. Bristlemouth is a bit of an experiment. It's basically building on the hypothesis, which is a simple hypothesis, but still a hypothesis, is that we need this. And I don't think there's a better proof or support of that hypothesis than this gathering today. Like the people here today that actually sort of like show up, work on this together with us and everybody else in the community to make this happen. In fact, I think it's so much proof that this is probably the last time we're going to be able to do this in this building because we're pretty much at the max of our occupancy level. So next year, somewhere else, we'll find a good spot for it. So thanks everybody for joining today. This is an exciting kickoff for 2025. But before we do that, I want to remind everybody why we're here. Why are we doing this? And for some of you, for many of you, maybe that's just because you really don't like RS-232 and want to get rid of like really bad connectors. And that's totally cool. But the real reason why we do this and why we put so much effort into building this standard is because it is foundationally important for understanding most of our planet. As all of you know, most of our planet is water. And we have a really, really hard time in scaling, sensing, and exploration in that environment. So effectively, we turned off the lights on most of the planet. And if you think about that from like a data quantity perspective, if you look at all the data we collect as humanity on an annual basis and equate that to the distance from here to the moon and back, the data we collect in the oceans today is about a meter, or I guess a yard if you're in a different sort of like metric system. But that's something that we absolutely have to change. And one of the biggest hurdles to do that is a technology hurdle. This is how we built stuff in the ocean today. It is, most everything we do, even the most mundane efforts, are engineering projects, which means that they are expensive, they're slow, they're generally fragile, and if it breaks, there's only one or two people in the world that can fix it for you, right? That doesn't scale. So what we're trying to achieve is that for most of those things, not all of them, but for most of those things, could we make it as simple as USB? And obviously, USB doesn't work in a marine environment, but the idea of USB does. And so what we've done with Bristlemouth is basically, looked at the best standards and examples out there and borrow and steal whatever we could. And that's not just because that's convenient. It's also a good idea because, we are a small environment, a small community, you should say. So for instance, borrowing hardware from other industries to make sure that it's going to be supported for a long time and, leveraging, decades of software development in other places so we can move fast and get to the outcome that we want, which effectively is an ecosystem of totally reusable modular building blocks. And so that's the end state that we have in mind. And everything we do today, over the last years and in the future, is going to be building toward that. So even the idea of applying standards is not new. Like it's a good idea. It works. It's been shown to work in many other places. Like CubeSats has completely and profoundly changed the way we do sensing from space. It has basically given us a completely new perspective on our own world. And we are convinced that Bristlemouth will do the same thing for the maritime space. So what have we done to date? There's going to be a lot of talk about that. There's a lot of progress. Don't take my words for it. You'll hear a lot about it today from other speakers and tomorrow, obviously. But at a really high level, about a year ago, when we had the first BristleCon, we kicked things off. And this is what we've done since then. We've basically shipped 100 Bristlemouth development kits to folks around the world. We have over 200 active forum users today, 7,000 page views, and we did 5 Bristlemouth events. So that is a lot. This is a bit of a side gig. We do other things here as well. So doing all of this in 1 year with all of you is an incredible level of progress. And there's a lot more under the hood, and Evan will talk more about that at length. But this is both, a starting point, like scratching the surface, and I think an inflection point. What we need to do next, and this is what we call phase 2, we'll probably come up with a better name in time, but what we need to do is 3 things, 3 pillars that we need to push on really hard to make sure that success is guaranteed. One is the technology. Today we have a subset of where we want to be in terms of like data, power, and depth, right? We need all of those things to be fully executed to make sure that we can do everything we want to do. The second part is community. We've seen this in the first phase of Bristlemouth, is that the community is key. This is something we built together. This is an incredible audience, by the way. The community of Bristlemouth is an absolutely unique mix of scientists, researchers, government agencies, venture capitalists, philanthropy, you name it, industry. That is an absolutely unique, but also a critical combination of groups, organizations, people to put their minds together and put their efforts together to make it happen. So this is something that we absolutely need to double down on. It's also a transition. Initially, the community is mostly developers. Now we're transitioning to getting more and more users on board, people that are just using the platform, and OEMs. This year, 2025, is the first year we're going to have 2 native Bristlemouth OEM sensors available. You can buy online and get shipped to your door. And we'll talk more about that later. But that's an incredible milestone for Bristlemouth. And the last part is the standard itself. Like, right now we have sort of like bootstrapped this, got this to go, make sure that this works. And this is something that the community needs and wants. The next step is that this has to become something that is self-propelling, self-steering. So we need to make sure that the controls and the steering of this standard lives in an entity that can persist beyond sort of where we are today. So those are the 3 things that we're going to work on. And we can't do that alone. And so I'm really, really excited to announce that we're partnering up with MITRE Corporation, Nick Rotker and his team, to help us with this. So together, we're going to tackle this, the 3 pillars in phase 2 to get to success. I'm really, really excited about it. So Nick could unfortunately not join us today. This was a last-minute emergency. He had to cancel the trip. I'm really excited that he managed to figure out a way to get a virtual attendance, and Amanda in the back of the room pushed really hard to make that possible. So Nick will be here virtually to share his perspective and on the partnership and working together to take things to the next level. And I'm glad we could make that work. So just to put things into perspective from the timeline, just to show you like how compressed things have been and how fast we've moved and how fast we anticipate to be moving going forward. About 1.5 years ago, we announced that we were going to make Bristlemouth an open source, completely open standard. We had our first BristleCon in 2024. I guess it was the end of 2023, about 1 year ago. Right now, we're start of 2025, kicking off the new year and getting ready to accelerate into the future. So what to expect for 2025? There's 2 main things which I think are critical and in line with sort of like the idea of an inflection point. One, we have 2 companies here today that are going to present the first native Bristlemouth OEM sensors, PME, AOS. They're going to talk about this incredible milestone for the standard, but I think also for the community writ large, that basically you can now get a sensor that is already Bristlemouth capable, from the get-go. The second part, and that's really doubling down on momentum, that's the partnership with MITRE and taking things to the next level. So the 3 pillars I just talked about: community, technology, and the standard itself. Those are the 3 things that we need to double down on. So we want to make sure that we are ready, in this year to complete that. Before I let you go, I want to turn it into like a little bit more of a philosophy note, which I like to end on. The last meeting we had, I brought up a paper by Eugene Wigner in the 1960s, talks about the unreasonable effectiveness of mathematics in the natural sciences. It's a wonderful paper. You should absolutely read it. This is bedtime material. But if you take it one step further, Whitehead posed that basically this is much more broad than just sort of like mathematics and natural sciences. It's basically the unreasonable effectiveness of standards in general. And with that, imagine this. If we have a lot of important but known operations, and we can simplify them to the extent that we don't really have to think about it very much and they become automatic, that means that we can use all our resources and headspace on the things that we don't know yet, and we can basically focus on innovation and not have to worry and spend resources on the things we already know how to do. Because that is the point where we are at in marine space. There are so many things that we do over and over and over again, and we spend so many resources on doing the same thing over and over again that it's really, really hard to get to scale and to get to progress. And so I like simple diagrams. They're usually wrong. So I'll give you one anyway, and you can do with it what you want. But if you look at this as sort of like a diagram that says like, look, what if we have no standardization And everything is innovation. So even the most simple things, you're going to have to spend the resources as if you're innovating something, which you really aren't. Like building a power supply should be something that doesn't require a lot of effort, but it would if there's no standards. On the other side, if the standard is like overly rigid and it doesn't sort of like allow innovation anymore because it doesn't adopt new technologies anymore, you're also in a bad space because now you have no innovation anymore either. So somewhere in the middle, there is sort of like, the best spot to be. And whatever the vertical axis is, I call it scalability of innovation. And that's a really bad term, but you get my drift. So if you put a graph on this, then ideally we want to be on the top of this summit, right? We want to get the maximum benefits of standardization. So a lot of the things that we do, we actually don't have to spend a lot of resources and effort, and we can really focus on pushing the envelope. And so the good thing is we don't really have to worry about the right side of this diagram because we're nowhere near that. We're somewhere there. Like we have no standard and we do everything sort of like as a one-off, and sort of like, everything is innovation. And maybe if we put that at BristleCon 1, so 1x BristleCon, and now we are at 2x BristleCon, then maybe we can measure our progress in units of BristleCons. So maybe, next year, 3x BristleCon, I hope to be really close to this summit, and I'll like to see you all there. So just to like close it off, we have a core value at Sofar. It's called Team Wins, and it really expresses the notion of the fact that there's not much you can do on your own, and if you want to make big impact, you're going to have to do it together with other people. I think this gathering here, the energy and drive we've seen over the last couple of years from the community writ large, I think is an incredible example of not just team, but community wins. So I want to thank you all of that, and I'm looking forward to hearing the talks today, connecting with most of you, and kicking off an incredible 2025 for Bristlemouth. Thank you. Oh, you go for it.
Yeah. All right, thanks. Thanks so much, Tim. Awesome. You guys will hear from me a lot today, so I'm just going to pass it off to co-founder and CTO Evan, and I'll just do a very brief introduction and let him get on with it. But a lot of the work that we all do here really hinges on seeing Evan smile. And whenever we plug something together and the smoke comes out, Evan's going to smile because it's hard. We know we got to dig and it's going to be hard, and he loves difficult problems. So I'll let you guys get to know him throughout the course of this event if you don't already, and hopefully we'll have some chance to bond later. So thanks.
Thanks, Zach. You got to earn the smiles. So I want to start by filling in a bit more of the detail of all that we have done in the past year. I think I need to do this so I'll believe it, because it's pretty extraordinary. So as Tim mentioned, we've put more than 100 Bristlemouth developer kits in the hands of people around the world. And these projects span academia to industry, government, and research. We have people who have successfully done things with Bristlemouth that we told them not to do because it wasn't ready to support it yet, and they pulled it off. It is amazing the pull that we've had from the community, and we have tried to stay together in lockstep, supporting all of the use cases we can. We've added numerous examples. We've had around a dozen individual developers contribute together around 500,000 lines of code to the core protocol repository. We have a new refactored repository that can support cross-platform development, so new processors. If you want to run Bristlemouth natively on your computer or Raspberry Pi, you want to use a different IP stack, we're set up for that now. And we have more on this tomorrow. So if you're sticking around for the technical sessions, you'll be able to meet with the Sofar engineers. You'll hear more detail on exactly some of the new features and what's been done here. We've also shipped a lot of physical stuff. Thousands of Bristlemouth components have been incorporated into products that have been deployed in the oceans, that have collected data that has been put into somebody's eyeballs, and decisions have been made because of that. And we are confident that this is going to continue to scale. The hardware has performed as expected. We've had excellent quality results, along with getting these into products and seeing actual systems go into the wild, we have sent components to other people who are building them into products. We'll hear from a couple of them today. They are taking these components, integrating them into new products, and these are going to be shipping this year. We're going to have more discussion on this later today and tomorrow on exactly what this kind of OEM track is. So if you're interested in building your own Bristlemouth-enabled devices so you can join the ecosystem, take advantage of all the capabilities in the ecosystem, please find Zach or myself. We definitely want to talk to you today or tomorrow. So we've done a lot. And looking to the next year, all of my predictions about how much progress we'd make and exactly what would happen last year, wildly off. I was wildly pessimistic at the pace of development and what would work, what would not work. So I feel much more like a phony soothsayer right now than a clear strategist who says this is exactly what's going to happen. I know the direction we're going, and I want to paint in a little more of how we're thinking about this, what we're prioritizing. But I'm not going to spend too much time on the technical details like I did last year. That presentation's still on YouTube. It's still all relevant and true. Find it and watch it if you didn't see it last year. One of the things that I set out is the end goal. And we always like setting the end goal and working our way back. The end goal here isn't connectors. It's not standards. It is enabling massively scaled ocean sensing applications, things that we don't have today. If you look out today at what is going on, we see very niche applications. We see some of the inklings of what we're imagining. But what we're imagining is ocean data at the fingertips of humanity in an unprecedented way, and that doesn't exist. There's a very simple second to last step that we know will inevitably result in this massively scaled future, which is that all marine technology manufacturers use Bristlemouth or some broadly adopted connectivity standard. As Tim said, the hindrance to scaling these applications, it really boils down to the integration complexity and the fact that we are innovating and re-innovating on problems that have been solved before. I also shared a kind of star map of how we get there. And so working our way backwards, there's a threshold where we don't need to convince all manufacturers that they should adopt Bristlemouth. We didn't have to convince everyone that Ethernet is the best thing or USB is the best thing. You get to a critical mass and they don't have a choice anymore. We'll drag the holdouts kicking and screaming where they have to do it because everyone else does it. And so this is probably small. It's like 25%. If 25% of the development community agrees on a standard, no one else has a choice anymore because they have such a tremendous advantage by having this compatible ecosystem. And so to convince that 25%, there's a few things that we need to make sure happen, which is that it's got to be really easy to integrate. We want to reduce the cost of deciding to do it. We need a business drive. We need users, people who are buying my stuff to say, what is Bristlemouth and why aren't you using it? We need an initial adopter set. And before we can have an initial adopter set, we need one. We need a technology that actually works. We need some application developers. This was the premise of Bristlemouth last year. We had a technology that we had put years of development into that we believed in. We had a commitment from Sofar Ocean, the first one manufacturer, that we would be on Bristlemouth. And I was imagining that we'd be able to fill in one more of these bubbles this year. But the sincere state is that we've moved a lot faster than we expected, which is exciting and terrifying at the same time. Sofar has fully adopted Bristlemouth. Everything that we produce is designed to connect to other things, and the way of doing that is via Bristlemouth. We have a wealth of applications going into the oceans. We want to get more. We're going to keep on working on that this year, get more Pioneer programs out, get more dev kit systems out so that more people can build applications with Bristlemouth. We have 2 manufacturers who are launching Bristlemouth products this year, which is going to It is a geometric or exponential scaling. It's not just 1, 2, 3. It's scaling with the ecosystem. The value just compounds and compounds. Bristlemouth, there's a proof point in that it is easy enough to integrate because people have done it. We can make it a lot better. We're going to work on making it a lot better. So there's a lot of OEM components and tools and developer support that we're going to be adding. And then I get phone calls from companies that I will not name who are angry because people are asking them about Bristlemouth and they've never heard of it and they don't want us to rock the boat. So I'm going to focus on a few of those bubbles. Today, we are at the cusp of industry adoption. In the coming years, we expect that there is going to be this compounding scaling effect where it's not driven by individual capabilities. Today, a lot of the applications are driven by individual capabilities. I want to do a thing. In the coming years, the capabilities are going to emerge from the more complex systems, and we won't be able to predict what they will be, and that's great. There's going to be these really complex interactions that'll allow people to do things that we haven't imagined. Today, you're going to hear from AOS, who are launching a product called Borealis, which is an intelligent acoustic receiver. It's got a sensor technology, hydrophone element inside of it. It is Bristlemouth native module. They'll have physical prototypes. It is small, it is low cost, it is category defining in power consumption, and it has this unique accessible embedded platform that is user accessible code space to run your own inference models, neural networks, whatever processing you can come up with. And it is plug and play in the Bristlemouth ecosystem. We're also going to hear from PME, who are launching the Microdot Plus, which is a compact, long dwell DO2 sensor. So it has the ability to consume power from a Bristlemouth network. It also has an integrated wiper. So this is a unique sensor in that it is designed for long dwell real-time applications, not a logger that you have to recover, not something that you're doing spot sonde surveys with, something that you will be able to set in the water and consume data in real time for 6 months, a year, very long dwell applications with minimal service. And you'll hear about that more today as well. As Tim mentioned, we're partnering with MITRE. You're going to hear from Nick Rocker soon. This is a little more structured and clean than how it's really working. We're really collaborating on all of this across the board in guiding Bristlemouth into its next phase of development. But there is a great complementary set of skills and experiences here, where MITRE is going to lead on setting up the steering. So collecting more industry stakeholders and input, connecting the Bristlemouth team to people who aren't at BristleCon today, and for good reasons, but we need to hear from them and we need to make sure the standard is as broadly applicable as possible. They have a wealth of experience in the art of standardization and finding that balance so that we invest the optimal number of BristleCons into the standardization and that we don't over-constrain things, but we don't leave it where it's too freewheeling and we don't get the benefits of that standardization and compatibility. And then finally, one of the things we're really going to be focusing on this year is setting up the governance so that Bristlemouth can be independent and self-sustaining forever. This should be an organization that can work autonomously in the marine space. There should be working groups. There should be committees. If somebody decides there should be committees, I won't ever decide there should be a committee on anything. But we need to make sure that we have the organization structure in place so that we're not relying on the kind of organic and hustle that we have today, and that we just really want to make it happen. That can't sustain it for decades, and we want something that is going to be a persistent staple in the marine industry. At Sofar, we are advancing the core technology at a healthy rate. We move as fast as we do on everything else. We get a lot of stuff in the water. We prove it by putting it out there, seeing what breaks, iterating and fixing it, and by connecting with and learning from you all who are using it. How can we make it better? How can we make it more ergonomic? What are the capabilities that it doesn't have today that are really holding you back? So that ties into the developer community. And this very tight-knit feedback loop between technology development and developer community, I think is the superpower of Bristlemouth and why we've been able to move so fast, and we're going to keep that going. And then the other thing that we now want to double down on is the OEM support track. We want to directly partner with manufacturers who are interested in using Bristlemouth. We will meet you halfway. Like talk to Kristen and Austin and Peter from PME, talk to Chris and Niru. We are doing this together. We're partnering. We're not worried about, wait, whose job is it to write this line of code or that line of code? Who's got the right hydrostatic pressure tests? Who's got the right access to the field? We'll do this with you. We can help you. We can make sure that it's successful, and we'll make sure that it's not successful only because you believe in the vision, but because it's going to make near-term business sense for both of us, where we can actually launch something new and get an immediate adoption. So on the technology roadmap, there's a lot of feature development that's happening in firmware and software. It's iterative, it's agile, it's continual releases. Join the developer digests that are periodically scheduled where you can talk to the engineers, look at the feeds on the community forums. For this Bristlemouth Phase 2, to be named something more compelling at a later date, we have mapped out where we think the next generation of capabilities are that will enable the next category of use cases expanding into vehicles and deep ocean operations. That is getting connectors manufactured by a variety of manufacturers that are all interchangeable, and the mated combinations will all be rated to at least 5,000 meter depth and wet matable. It is getting an additional data channel that coexists on the same connector that can deliver up to 100 megabits of data bandwidth. So that's for multiple real-time video feeds. And it's getting power delivery that can go up to 250 watts to a module. So thrusters, active optics, active acoustics, and power consumption that only costs the system 10 milliwatts per megabit of used bandwidth, which means you can still be a temperature sensor connected to a battery, and Bristlemouth is the best choice for you. Or you can be an ROV that has 5 cameras streaming raw real-time data, doing online neural networks, and Bristlemouth is the best choice for you. We're working with MITRE to map out this roadmap. I am not promising all of this will be done by BristleCon 2026. I expect more of it will be done than you'd guess based on how fast we're going. In the community side of things, we're going to continue the Pioneer program. So this is a mechanism where citizen scientists, researchers, student groups can get granted hardware to be able to develop on, to be able to put things in the water. We're also going to sell development kits commercially. And one evolution is to put Bristlemouth into classrooms. And so Vince Smith from Whalefall is leading this program. They got Bristlemouth development kits into the hands of high school students last year. I hope some of them are here today and we can convince them to be interns eventually, and then professional marine scientists and engineers. The goal for this year is to get Bristlemouth development kits and a guided curriculum into at least 100 classrooms. The output of those classrooms will be prototype modules that will be deployed in the water. The data will get back to the students in the classrooms, and we'll build this real tangible connection for the next generation of citizen scientists and engineers, and we get them while they're young for Bristlemouth. Vince will be sharing more detail on this in his talk at BristleCon. My last call here is really, please reach out to us if you think you should be using Bristlemouth. If you're an application developer, ask yourself if the capabilities that exist in the ecosystem today are things that you don't want to reinvent and are going to help you measure what you're trying to measure, save the ecosystems you're trying to save, manage the fisheries you're trying to manage. If you're an OEM, ask yourself if the capabilities that exist in the ecosystem today are things that your customers would love to be able to plug and play without integration engineering being a bottleneck, or if the thousands of Sofar platforms that are out in the wild and are Bristlemouth enabled might be a valuable addressable market for you to extend into. And a final shameless plug before I hand it over to Nick is that we are hiring. Check out our careers page and let us know if you might be interested.